Hello, General Math students. We are going to do a very quick probability video and stations unit during this last week before spring break. You're going to start watching this, and then I'll give you directions on what you're going to do after the video. So I would have your notebook out and your pencil, and this stuff is going to go into your notes. Anything that you don't remember. You've done probability before, but if there's something that you don't remember, then you should definitely do it. So let's get started. Probability. Probability is the likelihood of something happening, okay? And we kind of have a scale here. It starts out with impossible. If there's no way it can happen, then it's impossible is what we call it. It's got a 0% chance of happening. On the other end, we are certain that it's going to happen. It's a 100% chance of happening. Smack dab in the middle is equally likely to happen. That's 50%. Then anywhere between 50 and 100%, so that it's more likely to happen, we say it's likely. If it's less than 50%, but still kind of likely, we say it's more unlikely it's going to happen. So let's practice using these: impossible, unlikely, equally likely, likely, and certain. So let's go through these likelihood examples. What is your likelihood of getting into a car accident? That is unlikely. It's not ever going to happen, but it's not very often that it happens to you. How about winning the lottery? That is unlikely. As long as you buy a ticket, you have a chance. It's not zero, but it's unlikely to happen. Flipping a coin, you got heads and you have tails. So we have equally likely chance of getting one versus another. Rolling 2 die and getting a 7. Well, if you do all of the math, all the possibilities, 1 and 1, 1 and 2, 1 and 3, 1 and 4, and you keep on going, getting 7 is likely to happen. It's more than a 50% chance that you get a 7. Finding a 4-leaf clover. Again, it's not impossible, but it is unlikely. 70% chance of rain. 70% is more than 50, so this is likely to happen. Rolling 1 die and getting an 8. Well, people, there's only 6 sides. It's 1 through 6. You can't get an 8. This is impossible. It is never going to happen. There are 7 days in a week: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. That is certain. So one thing you might be asked to do is if it's likely, unlikely, or something like that. Outcomes. Outcomes are all the possible results of an experiment. And you're going to be doing 5 different experiments in the stations that you're going to be doing. An example, there are how many outcomes to rolling a dice? If you know, there's 6 sides, so there are 6 outcomes to rolling a dice. How about how many outcomes for flipping a coin? There are heads, there's tails. We have 2 outcomes of flipping a coin. An outcome is what all the possible results there are. So let's talk about theoretical possibilities. Theoretical is based on the perfect roll, perfection, and mathematics, okay? So the number of times a favorable outcome occurs over the number of possible outcomes. So let's look at the dice examples. And again, this would be great to have in your notes. Dice examples: the probability of rolling a 6. There's 1 6 out of 6 sides. So theoretically, if I roll a dice 6 times, I should get a 1, I should get a 2, I should get a 3, I should get a 4, I should get a 5, I should get a 6. So 1 out of 6 will be rolling a 6. How about rolling an even number? We have 1, 2, 3, 4, 5, 6. 3 of them are even. So 3 out of 6, better yet, simplify it down to 1/2, would be the theoretical probability of rolling an even number. Spinner examples. Let's look at the spinner right here. What's the again, we're still talking theoretical, okay? What is I can't spell theoretical. Probability of spinning a 5 or a 6. Well, we have 1, 2, 3, 4, 5, 6, 7, 8. So I know it's going to be out of 8. A 5 or a 6 is 2 out of those 8, or 1/4. Not spinning a 1 or a 2. So I'm not going to spin a 1 or a 2. I got 1, 2, 3, 4, 5, 6 out of 8. Or, again, simplified would be 3 out of 4. Let's erase my little marks here so that I know what we're talking about. Spinning less than 3. So this is less than 3 and this is less than 3. 3 is not less than 3. That's equal to 3. Again, we got 2 out of 8, or 1/4. Spinning a 10. There are no 10s on that whole thing, so that's 0 out of 8. How about spinning a 4 or a 7? So here's my 7, here's my 4. That again is 2 out of 8, or 1/4. Now, here's a good one. Spinning a 4 and a 7. Can we, in one spin a 4 and a 7? No, we absolutely cannot. That's a 0 out of 8. So the opposite, or I shouldn't say the opposite, but the flip side of theoretical probability is experimental probability. This is probability based on the results of an experiment. This is the top number is the number of times that it actually happened when you did it out of the number of times that you tried it. Again, a good thing to be putting into your notes. And one thing you guys should know by now, you can pause the video at any time to catch up. So let's take a look at some examples. If you have 20 emails in your inbox and 13 of them are junk emails, what's the probability of junk emails? Well, you have 13 out of 20. There's your experimental probability. At a vase factory, 4 out of every 20 vases are chipped. So what's the probability of a perfect vase? Well, if 4 are chipped, that means 16 are not. And we're just going to leave that as this so that we know the total number of vases that we have. You flip a coin 5 times. So here's going to be our bottom number is 5 times. It comes up heads 4 times. Well, theoretically, it should come up 2.5 times, or half the time, okay? Experimental, it actually came up 4 times. So our theoretical and our experimental are not necessarily going to match. Sometimes they might, but not always. How about you roll a dice 50 times? Here is our table, or our histogram, I should say, not a table. It's this is called a histogram, and you're going to be doing it a couple of times in your packet today. Here's what I rolled 50 times. I got a 1 10 times. I got a 2 4 times. I got a 3 8 times. What's the theoretical probability of rolling a 5? So if I roll a dice, it's going to be 1 out of 6. So the theoretical probability of rolling a 5 is going to be 1/6. The experimental probability would be right here. I rolled a 5 8 times. 8 out of 50. So there's our two numbers. This theoretical is in a perfect world, so 1/6 of the time I would be rolling a 5. This one is our experimental, what actually happened during the experiment. So theoretical versus experimental probability. Again, put this in your notes because you may get a question on this. Theoretical and experimental probabilities are not necessarily the same, not necessarily equal. They can be. Well, the question then, how do you make the experimental probability to be closer to the theoretical? The more trials that you do, or the more times you do the experiment, The more trials will get you closer to theoretical probability. So if you roll or flip a coin, your theoretical probability is 1/2. Your chances are you're not going to get 5 out of 10, but you are better to get 50 out of 100 or 500 out of 1,000. As you do more, you're going to get closer to theoretical probability. The last one is geometric probability, and this is based on space or the area of something. We're looking at the area of a given area, whether we want the shaded or the non-shaded versus the total area. Okay, so let's take a look at the examples. The probability of the shaded region, we have 1, 2, 3, 4, 5, 6, exactly same. 2 of them are shaded, so 2/6 or 1/3. The white region would be 4 out of 6 or 2/3. And if you put these two together, we should get 6 out of 6 if we're asking for the same for all the parts. Again, letter B, I'm going to have 4 because I've got 4 parts, equal parts. 2 of them are shaded, 2 of them are white. So again, that's 1/2 and 1/2. Again, we're just looking at the space. What about if they're not the exact same? Take a look at C. 4 is much bigger, okay? So what is the probability of spinning a 3? If you look, this space right here is 1/4 of the whole circle. How about spinning not a 2 or a 3? Again, not this, but the rest of this would be 3/4. Oh, 2 or 3. Sorry, I went 1 and 2. Let's try that again. Ooh, that I almost blew. Let's try it again. So not a 2 or a 3. So not the 2, and not the 3. Now the third is 1/4. The 3 is 1/4. The 2 is 1/8. So we have 1/8 for the 1 and 1/2. Let's put them together. 1/2 plus 1/8. So this would be 4/8 plus 1/8. That would give me 5/8. That way I'm not spinning a 2 or a 3. Let's take a look at D and compare them. Which is more likely? Spinning a green, which is right here, or spinning a 2, which is right here. Spinning a 2 is 1/4. Spinning a green is 1/3. So the green is more likely because it is bigger. 1/3 takes up more space than 1/4. Erase these so we don't get mixed up. Which is more unlikely? Spinning a 1 or spinning a blue? Well, that's kind of the exact opposite. A 1 is less space, so spinning a 1 is more unlikely. So after watching this video, you're going to pick up the purple, and I don't have a purple pen on this program. Pick up the purple What Are the Chances packet and do as much as the 5 stations as you can before Thursday. Thursday, I will be collecting. I will collect the packet on Thursday. And whatever is done is what you get done, okay? There's 5 stations. Just follow the directions. The materials that you need are on the back counter. And let me know if you have questions. Have a great day.